would like to welcome everyone again to our platform engineering talks. It's our webinar. We do a webinar every 1.5 months, so probably for everybody who just joined, we probably have talked a month and a half ago, or maybe if it's new for you, welcome to our webinars. Today we're going to talk about platform engineering and cloud computing, and this is something that's close to us, something that we do on a day-to-day basis, and we deliver this to all of our customers. And not only that we give them a platform to work with, but also an idea to kind of streamline their work and inspire them how to set up their teams and such. So before we start, let's look at our agenda for today. I'm going to do a short introduction about who we are, who Blackbird Cloud is, what our knowledge base is, and why we do these webinars. And then we're gonna dive into it directly with platform engineering, what the definitions is, what the benefits, when should you consider platform engineers and engineering, and also at the same time all the details about it. And then we're gonna go forward with the tool sets that's usually related for platform engineering. There are a few of those that is in our tool belt. I'm gonna get into it in detail later on. And then lastly, we're gonna talk more about the application onboarding. Hold on to me a little bit here. There will be a reason why application onboarding is quite an important thing. At the end, you probably will get it. And then we're gonna end it all with a short demo of how platform engineers, like a simple platform that we usually give. There's a really bare bone version, and then how the workflow looks like, and so on and so forth. So a bit of an introduction of who we are. We're Blackbird Cloud. We're a cloud development and consultancy company. We started way back around 2015. And we're a team of 4 at this point. At this moment, I'm Sakib Surur here. I'm the lead developer, cloud engineer for ChargePoint. For Blackbird Cloud. We mostly work with MKBs or medium or small enterprises, and well, sometimes also big companies. We give consultancy for them, or for some projects we run some sort of a DevOps team for them. We have backgrounds in software engineering and cloud engineering, so that means that we know exactly what the problem is, because we have experienced the issues before, and we kind of have seen all the development from all the sides that could be possibly there. A bit about Blackbird Cloud. These are the values that we hold dear and close to ourselves. We value 5 different things: reliability, partnership, expertise, transparency, and acceleration. So for example, today our webinar is basically us showing our expertise, and at the same time showing the transparency of what we work, how we work, and what is our thought processes are. And that's kind of like how we set up our company. Now, before I jump into platform engineering, I would like to maybe show a bit of context of what we see as a common pain of infrastructure team, be it an SRE or system reliability engineers team, or sysadmin or DevOps team, you name it. There's different naming for a group of people or a group of or a team that handles the infrastructure part of your cloud. What we see on normal basis that they're usually overloaded with infrastructure tickets. There are just a lot of stream of infrastructure changes. Database needs to be deployed. Network needs to be changed. User needs to be created, and those kind of things that came from the developer side. And giving the developer themselves the total freedom to create everything themselves is not really an option, because you kind of want to have some sort of a security guidelines or some checks in place to make sure that your cloud or your infrastructure is nicely deployed. And if you talk about DevOps, usually it's hard to put an infra guy on a team, because it becomes hard. Because there are short supply of people with expertise on infrastructure, especially for cloud engineers. So putting it on all teams, especially in a large context with multiple teams going on, like 20 teams, it's kind of hard to fulfill. And without these, then with all these problems that we have, it can be that the infra team might be a bottleneck for the whole value delivery of a company, right? So there's so much overloaded, and there's just short hands of people there. And yeah, when you have a stream of tickets coming in, they need to happen, but you don't have the time for it. That means you're going to be the bottleneck. Now, imagine if, let's say, it took a simple YAML or some configuration changes on a repo somewhere to deploy your application. So if there's a new team get set up, for example, that needs to create, I don't know, an HTTP server with database on it, and they could just simply say, okay, I'll just add everything that I need in YAML format or in a Kubernetes deployment or anything, and then you just commit it on a branch, make that pull request, and then once you merge that to main, and then it just happily deploys it automatically. That means that developers can manage their own release process. They could decide when to do and what to do. And not only that the developer should be able to release it automatically, but they should also get the feedback of their application, name it logs or metrics or monitor or anything. And a little bit of kind of like pushing the ideas, and some people are not comfortable with this, but you could also say the developer should be able to roll their own database or cloud resources. Of course, you need guidelines in place. We did the webinar about this in the past about security and cloud governance to support developer freedom. Might be worth it to check out that one for this specific thing. And then now let's just jump into it. Right, so we have that imagination. So what is platform engineering? Platform engineering is basically the discipline of designing and building tool chains, workflows that enable self-service capabilities for software engineering organization in the cloud-native era. Now, there are a few emphasize here that I put. The first one is tool chain, then next is workflow, and then self-service. Right? So for tool chains, it means that it's all about the tool chain and the workflow, right? How you set it up, what kind of tools you use, that is kind of the central point of all these. And then the self-service is an added benefits, right? So the self-service makes sure that you're not the bottleneck. That means that developers should be able to do their own changes, to do their work, and to roll forward or do any bug fixes automatically, those kind of things, right? You shouldn't wait for you to gatekeep everything. So again, like what I said before, this is more of a slightly in-depth of platform engineering. It's basically a continuous effort to unify application and resource deployments, right? So you can think of it this way: your applications usually are not that much different against each other or with each other. You could make some archetypes of your application. So think of your, let's say it's a Node.js application that always have an HTTP endpoint and it always connects to a database, right? You might have 10 different variations of those. Maybe you have a microservice architecture. Then you could say, okay, this is one archetype. And then maybe another one is like, oh, I have an event-based processing application that connects to Kafka and spits messages out to Kafka again. That's another archetype. And next to unifying the application, platform engineering really revolves around automation tool sets. Now, the automation part is really important here, right? I mean, it's logical. You want to be able to create a self-service. You want to move fast. That means that a lot of things have to be automated. So deployments needs to be automated. Maybe user management needs to be automated, and those kind of things. Now, platform engineers actually enable DevOps within the teams with limited amounts of engineers, because you can pool all your infra, like your expert infrastructure people into one team, and then say to that team, hey, make the best platform ever, and make sure that our developers won't be bottlenecked by anyone here, right? So they could think about how they want to set up the processes, the workflows, and the automations for that, and that will kind of enable these DevOps things that the developers can do without the burden of thinking about their own deployment, right? So you create some sort of an automation and guidelines and some templates, and maybe your self-service portal, you name it. So what does it all bring at the end? It will increase the velocity of value delivery, right? Because your developers are not gatekept by you anymore or bottlenecked. And at the same time, you could set security and quality level checks, right? So you could automate these processes as well with like merge request checks or automatic scannings or you name it. We'll get into the details slightly later. But for now, from the developer side, what the benefits are that it had to, well, it's actually a lower cognitive load for developers to think about how their app needs to be deployed, because you already created the archetype, you already created the template, all they have to do is just follow it. And if they have some changes, they're free to do so. But yeah, I mean, the whole checks and balances are in place, then it should be okay. It allows for smoother scaling of teams. So you don't have to hire for every team that you want to spin up. For example, you don't have to hire a new infrastructure people there. It just scales because you have a platform that maybe 10 developers or 10 teams can use, or maybe more, and then you could even scale that even further beyond. So it's just the platform itself needs to change probably. One thing, I think I mentioned this briefly before, I have to consider before jumping into platform engineering, you have to look at your team size. So if it's just a team of 2, or maybe you have only 2 applications or 2 services running, platform engineering doesn't really help, right? It just bogs you down. But imagine if you have 10 teams of developer working, or maybe 2 teams, but with hundreds of applications out there. They do microservices or you name it, and that's really when platform engineering starts to shine. Now, to make a platform or to do platform engineering, there is a time investment that needs to be put in place, right? So that's why you need to be careful, or not really be careful, but like choose when to start doing it. But shouldn't be too late. It shouldn't be too early neither. So there's a balance spot there. Those investments that will be made, that will have to be spent during the engineering phase of a platform, will be worth it at the end, because again, then it will allow you to smoothly scale your team up, and also at the same time give values to customer fast. So, what are the components of platform engineering? There are a few of those. It always starts with a Git repository, right? So we always advise to do an infrastructure as code kind of approach. A Git repository helps you make your changes transparent, reproducible, and also you could control who can make the changes, and you could add checks and balances in place, like with pull requests and such. That kind of helps making the platform slightly more robust in that way. And then CI/CD components, where your code or developer should be able to run tests automatically, or build automatically, and at the same time deploy automatically, right? So you could have an automated process there with your CI/CD. I'll go into detail with all these. There are a few tools that we suggest to use, but for now, let's go on forward. Next is orchestration system. Orchestration system is basically the runtime of the application itself, or a way to kind of deploy the resources, not necessarily the CD part, but deploy the resources in your cloud, whether it's albeit it's a Kubernetes platform, for example, to run your application, or maybe you want to have an ECS platform to run the application with, let's say, what is it again? CloudFormation, where you could just say, okay, just run these application, all these stacks, and the infrastructure is there, the application is there, and it just simply orchestrates the running part. And then last but not least, this is also important, logs and monitoring access. Right? So the developers, not only that they need to deploy the application, but they also need feedback. Right? So if I deploy something on production, I want to see the logs if there's any issue. I want to see how the application performs on production. Maybe if there's any alerts that I want to set, because, well, I want to make sure that whenever there's an issue, I need to know immediately. So for logs and access, usually it tends to be simple. There are a few things that we need to keep an eye out for requirements. But yeah, that's the components. Now let's dive slightly deeper per component. First, we're going to start with Git. As I said before, infrastructure as code is key here, right? So it allows for transparent changes to make sure that your code are auditable. You can see who changed what, when do they change it, and so on and so forth. You can add access control on top with pull requests, a protected branch, and many other features. Again, like what I said before, it allows for review processes before rolling out, making sure that your changes are properly reviewed, so that it's not only that one guy will do all the changes or can do all the changes, and that means that your process is slightly well organized in that way. And lastly, usually for us, it's a hosted solution, whether it's GitHub or GitLab. They offer all of these features out of the box, and they also have automation with actions or pipelines, and yeah, that's quite nice to have. Next is CI/CDs, right? Again, with the one before, with GitLab and GitHub, they have pipelines and actions. That's usually good for your CI. You could just make sure that your code is tested and built as automated there. And maybe you could use that as well for your deployments. If it's a cloud formation, for example, you can just say, okay, every time you commit something to master, build the image, change the cloud formation templates, and then send it to AWS, and then let them figure out what the new state will be. Many of the CD tools are there. You can just pick one. And we like Argo, for example. Argo is one of the nice tool. I'll do a short demo on Argo. Basically what Argo does, it checks your repository, see if there's a Helm chart there, and make sure that all the values that are there, or the Helm deployments that's there, are synced with your Kubernetes cluster. So in that way, then you could have your infrastructure there and all the codes that is necessary for your applications in the repository. Next is an orchestration system. What an orchestration system does, again, it manages the application deployments, right? It deploys or provision infrastructure based on requests. So you could just run your code there, and you say, like, okay, I want a database with Crossplane, for example, and I want a Redis, and I want a Kafka, and I want my application to be running with 3 replicas. That's something that you just create, and then it will just happily create the infrastructure that you need. And Kubernetes, you can do that. In CloudFormation, you can also do the same thing. Usually for orchestration system, one of the nice thing to have is a containerized system like Kubernetes, because, well, containerizing your application will help you with dependencies management, so you don't have to go to a machine and then copy paste your changes there, then make sure that all the dependencies are there. So it's nicely just containerized and neat and you can just deploy it anywhere as long as it has an orchestration system. And then next, last but not least, is the logs and monitoring access. Usually we just choose run-of-the-mill log and monitoring. As long as it has an access control system in it, that should be okay. It's highly important, as I said in the beginning, for developers to debug or monitor their application, because then they could just see what the effect is of their deployments, of the performance of their deployments, or if there's any issues and so on and so forth. They could add the alerting and such. Most of the time we rely on something that's available to the cloud, depending on where we're deploying. So if we're deploying on AWS, for example, we usually choose CloudWatch for our logs and monitoring access. But sometimes there are some requirements that's not supported by CloudWatch. But then for that, we do a self-managed Prometheus and Grafana. And for logs, we can add Loki there. It's quite easy to deploy. Usually it's on Kubernetes, and you can just Helm install all these components in your cluster, and then it will just happily be there. And now the demo part. So what I have prepared for the demo is sort of a small platform where developer can create application repositories and include the deployments for the repositories, and a centralized repository with all the application definitions, right? So on the top here, you see the application bootstrap repository. It's on GitHub. It's public. I think you can all access it, see what's up there. The application bootstrap repository contains all the application that needs to be run, right? And there is a Kubernetes that I've deployed on EKS here. There's an Argo running. Basically, the Argo application here, the application bootstrap, will listen to everything on the bootstrap repository, and then it will deploy the applications based on what's in the bootstrap. I'll show you how it works in a short while. Right now, I have two applications, application A and application B. They're in different repositories. And then we're going to try to onboard application C and see how that process looks like. All right, and I'm going to share my screen. So I have here the Argo UI. This is what you will see with your Argo application. I have here three applications: the application bootstrap itself, application A, and application B. In the bootstrap, you will see all the applications again, right? So this is basically an overview of all the applications. They're all related back to the application bootstrap because it's just an application that spins another application. The application bootstrap right now deploys two applications with three resources each. You have the namespace, that's a Kubernetes namespace, a service account for application A, and then the application A itself. Right, so these you can even increase. You could configure, for example, the service account on the application bootstrap repository, and hook it up with another IAM, for example. And here, the application A is simply just another application on Argo, right? And it contains all the deployments, or all the components, or all the assets for application A to run. Right, so it has a service, it has a service account again, and it has a deployment. This is just your normal run-of-the-mill application. Nothing fancy. It's just running Nginx right now and nothing else. So how does it look like on your repo? So I have here the sample repository for the platform engineer, or the platform that I showed. Right, so there are two files: the application bootstrap itself and the application repositories. Usually the application repositories doesn't live in this repository. It's somewhere else. But just for simplicity's sake, so that we could see everything in one go, just put the file here for me. And in the application bootstrap itself, it basically is a Helm chart, right? And the Helm chart actually contains out of 2 dependencies. We have here a 2 Helm charts. It's called application bootstrap. That is alias to application A and application B. Now, this application bootstrap Helm chart is just a simple Helm chart that we have that's also publicly available. It does nothing but just deploy an Argo resource on Kubernetes so that Argo CD can just look it up and then spins up all the resources that it needs. Right, so that basically creates the application here that you see in this one. So these 2 applications here are just the Helm chart that we just saw. And here on the details, as you can see, this application is pointing to this repo, which we just looked at. It looks at the main branch, so it will make sure that everything on the main branch is synced. And this is the path that it needs to look up to find the Helm charts, right? So it already contains all the values. And with Argo, you also have the option to add more configurations there. So let's say if you want to inject database secrets on your Helm deployments, you don't want to commit that to your code, but you can just inject it on Argo level, and so on and so forth. So there's a feature-rich CD system here that Argo have. Now back to the application deployment. Here we have application A and application B. So what is an application A? So application A, basically, if I go there, I could also show it here. It basically creates another Argo application, right? And it just makes sure that it just points to a different repo. Well, in this case, it's the same repo, just different folder. But you can just point it to any repo, and you can even point it to a private repo with some credentials, and that's all good. So in this case, it points to application A deployment. Now, what is in application A deployment? Let's see. So we get the application repositories, application A, and imagine that this is a single repo, right? This is just a Node.js app with your default source, your package JSON, your get ignore, and you have your application logic here. Maybe your build is also here, your Docker image build. And here there's just a deployment folder. And inside the deployment folder is actually where the deployment is, right? So it's another Helm chart of how the application looks like. So you can have your own Helm chart here. This is just a sample Helm chart with Nginx running. You could have your values so you can configure all your applications here. And you could also overwrite the configurations here from Argo. That's also an option for secrets and such. And yeah, so let's say now we have 2 applications. What would happen if we want to include the third, right? So let's say application C is now made. Somebody made it. So here I've prepared a pull request for application C and onboarding application C. Again, right, so it's infrastructure as code. That means that people could just go to this repo, add their application, and say like, hey, run this application, please. And what do you have to do? Well, in this case, then you just have to go to the values of the application bootstrap and say, hey, you know what? Right now there's application C running. So then once you have this, then you can just commit this and merge it. And then once you merge it, then Argo should be able to pick it up and deploy application C. Let me give it a try, but I think I missed something. 1 second. So I have it open here. Status. So I'm in main. Oh. Stash, please. Oh, nothing. Okay, sure. So I have to add something that's missing here. Application C is missing. I'm gonna change that. Hit slash hit check out. What was the feature branch again? Onboard application C. Oh, this is there, of course, gone. Apply, git add, git commit, added application C, push. All right, so now I think this should be good to go. So if I pray to the demo god, then if I merge this change, I'll go back. So if I merge this change to main, then it should automatically create application C. Applications, go to application bootstrap. If I refresh, should see my changes. Yes, hey, there you go. So now it sees my changes, right? So I merge my changes to main, and it just happily sees, hey, you know what? There's a new application that I need to run. So now it happily run application C, and at some point it's going to say sync OK. There's one warning, don't know why, but it says now it should automatically sync. I think there's just, it just takes a little bit of time to create the service account. So now I have application C running. And that's it. That's all a developer has to do to deploy their application. And yeah, I hope that's clear for everyone. And that's the demo. Now, we're slightly over, but let me see if we have questions. I think there was one question somebody asked on the chat. So I got a question from Danny. What are the main challenges of implementing platform engineering in the cloud computing, and how can they be overcome? So one of the challenges that we see for platform engineering is always the complexity of the workflow or the way the application is deployed. And usually to overcome that, we create the archetypes, like what we mentioned before, of the applications, depending on what is currently available, how it's currently configured, right? And with that archetype, we kind of simplify the complexity a little bit. And also at the same time, we need to be able to make sure that the developers can kind of wiggle around on that archetype of applications, of templates, right? So if, let's say, the archetype of the application or the templates of the application is to have just a Node.js application with an HTTP endpoint and a database and a Redis, the developer should also be able to say, okay, I'm going to take this archetype and I'm going to change a little bit on the Redis part. Maybe instead of Redis, try something else. They can do that. Right? So just making sure that that system in place, and at the same time having a template where developers can just use immediately and get going really fast. That's how we kind of overcome the complexity issue. Yeah, I hope that answers your questions, Danny. And let's see if there's anybody else have a question. I'm gonna give it one more minute. Nothing. Well, I guess that is it then. I would like to thank you everyone who attended and who are paying attention to the platform engineering talk that we did. If there's any questions, or if you have any ideas or thought about this, feel free to contact us. And also the Git repository is available for everybody to see. And that is it then, I guess. All right. Thank you, everyone.